How is selective breeding done? Let us understand this concept with the help of a few AI-generated images, where first you need parents to have offspring. Here we have our first parent who naturally exhibits red hues. Besides this trait, the cotton parent is not useful from an agricultural perspective. This is the second parent. This cotton plant exhibits desirable agronomic traits such as high yield, disease resistance, or fiber quality, but with white or non-red cotton fibers. What you see here are the parents or the initial generation. The first step of breeding is to pollinate the flowers of the white cotton plant with the plant bearing fibers of red hues. The resulting seeds are grown into plants. The plant babies that we can see here are the first generation of hybrids. The plants of the first generation are allowed to grow until they bear the cotton. These cotton are then observed for their traits. Those with a hint of red pigmentation and desirable fiber qualities are selected. The selected hybrid of the first generation is pollinated or crossed back with the original white cotton parent. This is called backcrossing as the parent is back in the equation. This helps reinforce the fiber traits of the white cotton while strengthening the red pigment trait that we want. The resulting generation is called the backcross generation 1, and the plants with the best combination of red pigmentation and fiber quality as a result of the backcrossing are chosen. The chosen plants in the backcross generation 1 are then subjected to cross-pollination. So what is cross-pollination? Cross-pollination is conducted within controlled environment. The seeds generated as a result of the cross-pollination are then sown. The plants growing from these seeds form the second generation. The second generation plants are evaluated for enhanced red pigmentation and further improvements in fiber quality. Select the best second generation plants based on red pigmentation and fiber traits. Once again, subject these plants to cross-pollination to continue reinforcing and stabilizing the desired traits. As you can understand by now, it takes multiple generations in order to stabilize the traits, which are red pigmentation and high quality fiber. So you can just imagine it's not that easy and it takes relatively longer period, which involves cross-pollination, the resulting seeds which are then sown, and the plants which grow out of these seeds are allowed to grow until they can bear the cotton, followed by observation of these traits. Once the traits are stabilized, only then can these new red pigmented cotton variety with the qualities from the white cotton plant, which includes high fiber quality, can then be commercialized. If whatever I just explained swooped right over your head, or you want a relatable example, just remember this. You need at least 2 paint colors to create a shade. It takes you not one, but several tries to get the right shade. Similarly, it takes several tries to get the right hybrid in selective breeding.